Look up into the night sky. Beyond the city lights, a tapestry of stars unfolds. Countless suns scattered across an ocean of black, each one a potential home. And around them, a silent cosmic question echoes. A question we have asked since we first learned to dream. A question that defines our search for meaning. Are we alone? For all of our history, we have been a species that looks up. We saw gods and monsters in the constellations. We saw omens in the passage of comets. The heavens were a mirror for our myths and our fears. They were divine, untouchable, a realm beyond our own. Then a revolution happened. A simple act of looking closer. In the 17th century, an Italian astronomer named Galileo Galilei pointed a new invention toward the sky. His telescope revealed a universe of shocking detail. He saw that the moon was not a perfect, smooth orb. It was a world scarred with mountains and craters. He saw that Jupiter was a king, attended by its own court of tiny moons. The points of light were not just heavenly lamps. They were places. Suddenly, the universe was no longer just a ceiling above us. It was a landscape of infinite worlds. And if there were other worlds, could there be other life? The question shifted from the realm of myth to the realm of science. Our curiosity ignited. We began to search for neighbors among the stars. At first, our search was naive, colored by our own experience. In the late 19th century, observers claimed to see canals on Mars, vast, straight lines crisscrossing the red planet. They imagined a dying civilization building global irrigation projects, a desperate attempt to survive on a drying world. The idea captured the public imagination. It was a story of a world like ours, but older and wiser. But as our telescopes improved, the dream faded. The canals were revealed to be optical illusions, combined with the human brain's desire to see patterns. Tricks of light and shadow, cold and seemingly lifeless. Mars was a desert world. The silence from our neighbor was profound. It became clear that if we wanted to find anyone, we would have to listen. The idea was simple, yet radical. Perhaps an advanced civilization would use technology we could understand. Perhaps they would communicate using the most fundamental medium in the universe, radio waves. In 1960, a young astronomer named Frank Drake decided to try. He pointed a radio telescope in West Virginia toward two nearby sun-like stars. The project was called Ozma. For 2 months, he listened, searching for a single artificial pattern in the cosmic static, a whisper of intelligence in the roar of the universe. He found nothing, but the search had officially begun. Drake realized the challenge was immense. To guide the search, he devised an equation, a formula to estimate the number of habitable civilizations in our galaxy. It is now known as the Drake equation. It takes into account factors like the rate of star formation, the fraction of stars with planets, the number of those planets that could support life, the fraction of those on which life actually arises, the fraction of life that develops intelligence, the fraction that develops detectable technology, and finally, the length of time they release detectable signals into space. The Drake equation does not give us a final answer. That was never its purpose. Its purpose was to organize our ignorance, to break down an overwhelming question into smaller, manageable parts. It is a roadmap for the search. Each variable, a frontier for scientific discovery. It told us what we needed to know, and it inspired a global effort to listen. This effort became known as SETI, the Search for Extraterrestrial Intelligence. For decades, SETI projects around the world have scanned the skies. Using massive radio telescopes, they listen patiently, sifting through an ocean of natural noise from stars, pulsars, and galaxies. They are looking for a needle in a cosmic haystack, a signal that stands out, a signal that could not be produced by nature, a beacon deliberately sent by another mind. For years, the search yielded only silence. The universe seemed stubbornly, profoundly quiet. Then, on a summer night in 1977, something happened. It was August 15th, at the Big Ear Radio Telescope at Ohio State University. The telescope was conducting a SETI survey. Its data was recorded by a computer on long sheets of perforated paper. It was the job of a volunteer astronomer, Dr. Jerry Emin, to review the printouts. It was a tedious, repetitive task. Scanning endless columns of numbers and letters representing signal strength, but on one page, his eyes stopped. He saw a sequence of characters that made his heart race. 6EQUJ5. To an outsider, it was meaningless. To a radio astronomer, it was a thunderclap. The sequence represented a signal of extraordinary power. It was narrowband, exactly what you would expect from an artificial transmitter. It was 30 times stronger than the background noise of deep space. It appeared in the telescope's field of view, grew in intensity for 36 seconds, and then faded as the telescope moved past it. The total duration was 72 seconds. The signal had all the hallmarks of a non-terrestrial and non-solar system origin. Emin was so stunned, he circled the sequence in red ink, and in the margin, he wrote a single word. Wow, the wow. Signal became the most famous candidate for an alien message in history. The telescope was immediately pointed back to that same patch of sky. Scientists listened again and again, but the signal was gone. It has never been heard since. For decades, researchers have tried to explain it. Could it have been a signal from a military satellite? A reflection from a piece of space debris? A rare, undiscovered natural phenomenon? No terrestrial explanation has ever fully fit the data. The signal came from a region of space where there are no known planets or stars. A seemingly empty patch of the constellation Sagittarius. The mystery endures. Was it a fluke? A ghost in the machine? Or was it a fleeting, overheard whisper from a distant civilization? A message in a bottle, whose sender we may never find? The wow. Signal taught us a crucial lesson. Listening is not the only way to search. We also needed to look. For most of history, planets outside our solar system were pure theory. We assumed they existed, but we had never seen one. That changed in the 1990s. Astronomers developed new techniques to find these exoplanets. The most successful was the transit method. When a planet passes in front of its star, it blocks a tiny fraction of the star's light. This causes a slight periodic dimming. By monitoring thousands of stars for these telltale dips in brightness, we could infer the presence of orbiting worlds. NASA launched the Kepler Space Telescope in 2009. Its mission was simple: to stare at a single patch of sky, to monitor 150,000 stars searching for planets. What Kepler found changed our understanding of the galaxy forever. The results were staggering. It turns out that planets are not rare. They are everywhere. The data suggests that there are more planets than there are stars in the Milky Way. Our galaxy is teeming with worlds. Hundreds of billions of them. Kepler found planets of all kinds. Gas giants larger than Jupiter, orbiting scorchingly close to their stars. Super-Earths, rocky worlds larger than our own. And most tantalizingly, it found planets in the Goldilocks zone, the habitable zone. This is the region around a star where conditions are not too hot and not too cold, where liquid water could potentially exist on a planet's surface. And where there is water, there is the possibility of life as we know it. Kepler and its successors have found thousands of potentially habitable worlds. The silence of the universe was not due to a lack of real estate. The galaxy is full of potential homes. But this discovery raised a new, more difficult question. If we find life, what will it actually look like? Our imagination is often limited. We picture aliens as vaguely humanoid, with big eyes and green skin, a product of our own biology and culture. But the universe may be far more creative than that. The clues to what alien life might look like are not in the stars. They are right here on our own planet, in the most extreme and inhospitable places imaginable. We call them extremophiles, life that thrives in conditions that would kill a human instantly. Journey deep into the ocean to the crushing blackness of the seafloor. Here, volcanic vents spew superheated water, thick with toxic chemicals. It is a landscape from another world. Yet it is crowded with life. Giant tube forms with no mouth and no stomach thrive here. They live in a symbiotic relationship with bacteria that feed on sulfur. Life, powered not by the sun, but by the chemical energy of the earth itself. Travel to the boiling, acidic hot springs of Yellowstone. The water is as corrosive as battery acid. They have adapted to an environment we would consider hellish. Explore the driest deserts on Earth like the Atacama in Chile, places where it hasn't rained for decades. Crack open a rock and you will find a thin layer of bacteria inside, hiding from the deadly ultraviolet radiation, surviving on mere traces of moisture. Drill 2 miles beneath the Antarctic ice sheet. You will find subglacial lakes of liquid water, sealed in darkness for millions of years. Even here, scientists have found microbial life, a hidden ecosystem completely isolated from our own. These extremophiles have rewritten the rules for life. They show us that life is not a delicate flower. It is a tenacious, resilient, and adaptable force. It can exist in crushing pressure, searing heat, freezing cold, and lethal radiation. This has profound implications for our search. It means that the habitable zone might be much wider than we thought. Life may not need a gentle, Earth-like world to take hold. It could be hiding in the thick, acidic clouds of Venus, or in the dark, subsurface oceans of Jupiter's moon, Europa, or Saturn's moon, Enceladus, which sprays geysers of water into space. And it could be hiding on our next-door neighbor, the one we have been curious about all along, Mars. The search for life on Mars is no longer about finding canals or cities. It is a forensic investigation. NASA's rovers, like Curiosity and Perseverance, are robotic geologists. They are searching for clues in the ancient Martian rocks. They are not looking for Martians, they are looking for biosignatures, the chemical fingerprints of past life, specifically microbial life. What they have found is tantalizing. The rovers have driven across the dried-up beds of ancient lakes and rivers. They have found clear evidence that billions of years ago, Mars was a different world. It had a thicker atmosphere, warmer temperatures, and liquid water flowing on its surface. It had all the necessary ingredients for life as we know it. Did life arise there? That is the billion-dollar question. The Perseverance rover has found complex organic molecules in Martian rocks. These are the building blocks of life. They are not proof of life itself. They can be formed by non-biological processes. But it is a discovery in the right place with the right ingredients. The rover is now collecting rock samples, sealing them in tubes to be left on the Martian surface. A future mission will travel to Mars, pick up these samples, and return them to Earth. For the first time, we will be able to study pristine pieces of another world in our most advanced laboratories. Within those rocks, we may find the definitive answer, the fossilized remains of a single Martian microbe. A discovery that would change everything. It would tell us that life is not a miracle unique to Earth. It is a common cosmic process. If it happened twice, right here in our own solar system, it must have happened billions of times across the galaxy. And this leads us to the greatest mystery of all, the overwhelming, deafening silence. It is a paradox, first formulated by the physicist Enrico Fermi, the Fermi paradox. It goes like this. The universe is ancient and vast. Our galaxy alone contains hundreds of billions of stars, and likely hundreds of billions of habitable planets. Life, as we have seen, is incredibly tenacious. Given billions of years, some of that life should have evolved intelligence. And some of that intelligence should have developed interstellar travel, or at least interstellar communication. Even at slow speeds, a civilization could colonize the entire galaxy in a few million years, which is a mere blink of an eye in cosmic time. So ... where is everybody? The silence is the most profound piece of data we have, and it is deeply unsettling. Scientists have proposed many possible solutions to the Fermi paradox. Each one is more thought-provoking than the last. Perhaps there is a great filter, a step in the evolution of life that is almost impossible to overcome. Maybe the jump from simple cells to complex life is incredibly rare. Or perhaps the filter is still ahead of us. Perhaps all advanced civilizations inevitably destroy themselves through war or by wrecking their planet's climate. The silence could be a warning. Another possibility is the zoo hypothesis. Perhaps advanced civilizations exist, but they have a strict policy of non-interference. They are observing us like we observe animals in a nature preserve. They are waiting for us to reach a certain level of maturity before they make contact. We could be living in a cosmic wilderness deliberately kept pristine. Or perhaps we are simply too primitive to understand. Their communication might be happening all around us, using a form of physics or technology we cannot yet comprehend. It would be like an ant on an anthill, trying to understand the internet signals passing through it. The universe might be a busy, noisy city, but we are deaf to its conversations. And then there is the most humbling and perhaps the most terrifying possibility, the one that places us at the center of a great cosmic stage. Perhaps we are the first. Perhaps life is common, but intelligent, self-aware life is a fluke, a 1 in a trillion accident, or maybe in all this terrifying immensity, across billions of galaxies and trillions of worlds, we are truly, utterly alone. The search for life beyond Earth is more than a scientific question. It is a search for ourselves. It holds a mirror up to our hopes, our fears, and our place in the universe. Every potential answer is profound. If we find life, we are no longer the sole proprietors of consciousness. We become part of a larger cosmic story. Our perspective on everything, on religion, on philosophy, on our own importance would shift forever. But if we search for 1,000 years and find nothing, if the silence remains unbroken, that discovery is just as profound. It would mean that this tiny blue world is the only outpost of life we know. It would make every forest, every ocean, every living creature infinitely precious. It would make our squabbles and divisions seem impossibly small. It would place upon us a sacred responsibility to protect the only spark of consciousness in a vast, empty darkness. So we continue to listen, we continue to look, we send our robotic emissaries to other worlds, and we point our greatest telescopes toward the silent stars, driven by the same ancient curiosity that first made us look up and wonder. The search continues, the question echoes, and the universe waits. Thank you for joining our journey tonight on Story Drop. If this story sparked your curiosity, your support with a like and a share is what keeps us going. The universe is full of mysteries waiting to be explored. Share in the comments what topic or enigma you'd like to see in our next story. Until we meet again, stay curious.